In today's class, we will study about uniform plane wave. So in the last class, we have seen what is an electromagnetic wave and how an electromagnetic wave propagates. So what are the properties? So we understood that it's a combination of electric field and magnetic field. And then later we derived the wave equation by using Maxwell's equations. So we have seen what all the equations we have used. And we have done that for free space where sigma is equal to 0 or volume charge density rho v was equal to 0, and we derived the what we call the wave equation. Now we will see what is a, so that was for a free space. Now we will before moving on to a conducting medium where we have a sigma, where charge density, where sigma is not equal to 0, we will study about uniform plane wave. So let's see what is a uniform plane wave. Maybe you will get a theory question, or mostly they ask only derivations and numericals from here, but still we'll see, because anyhow they need to ask 20 marks from this module, right? So everything is important. This is a very small module. So uniform plane wave is the simplest case of electromagnetic waves. So we have studied about electromagnetic waves, which is a combination of electric and magnetic field, right? So what does uniform mean? Uniform means here the field is not, so you know there are three coordinates, x, y, and z coordinates. Uniform plane wave means the electromagnetic wave while propagating is not depending. It has no depends on the coordinates x and y, and it depends only on that coordinate on which it is propagating. Remember the figure which I showed you in the first class field where they were propagating along one axis. So here we will consider it is propagating along z axis. So consider that as z axis itself, because that time we didn't name the axis, right? So here uniformly plane wave means it is not depending on the other two coordinates, depending upon z axis, and it will depending upon time itself, depending upon the direction of propagation and as well as only on the time. So we can the wave equation will be updated to as per our studies, because we are considering only electric field intensity and magnetic field intensity. So we need not consider the other two transverse coordinates, z and t. So that's the basic understanding of uniform waves. And when we move ahead, we can see that this is actually the direction of propagation. The same figure which I have shown you with the wave figure. That's the same thing, because we have derived the equation. We have derived a wave equation in the previous session, right? But for the wave equation which we have derived in the previous section, the solution of the wave equation derived in the previous section gives electromagnetic waves, right? So electromagnetic waves, and they will be having an electric field and magnetic field, and this is how they will be propagating. So you can see here that I have shown you it is propagating along the z direction, right? Propagation here, electric and magnetic field lie on the same plane, independent of x. And so if somebody is asked, if you get a question, what is uniform plane wave, then the main difference is in a uniform plane wave, electric and magnetic field, they lie on the same plane. In this figure also, you can see that it is along z direction. So you can see how electric and magnetic perpendicular. Here, electric and magnetic field, they are mutually perpendicular to each other, and so they are also called as transverse waves. Since they are mutually perpendicular to each other, they are also called transverse. Also, just uniform plane wave, and maybe you can write some properties also. So, properties of uniform plane wave at every point in space, which is very important examination point of view. At every point in space, electric field, I'm using the simple, and magnetic field are perpendicular to each other, and also to the direction of travel. That's what I will. Then second point I will write down here: frequency of electric and magnetic field. Frequency of electric and magnetic field should be same in space, so we call it a uniform plane wave. So that's all about uniform plane wave. Just a basic understanding is required. So then we will be deriving for a uniform plane wave how the wave equation behaves for a lossy medium, lossy dielectric medium. So such things we will see. So now we will see the wave equation for a conducting medium. So conducting medium means it will be having charge carrier. Sigma will not be equal to 0. So you know that basically you know the equation del cross E is equal to minus dou by dou T of mu H, and you know that B is equal to mu into H, D is equal to epsilon into E, you know that. Then also we have seen del cross H is equal to J plus dou D by dou T. The what is the ampere circuit? So all these things we have seen. So now we will take the curl here. Taking curl on both sides, it will be del cross E equal to minus of mu into dou by dou T of del cross H. So it will be del cross E equal to minus mu into dou by dou T of, so del cross H we substitute for J plus dou D by dou T. Then you know there is a vector identity, del cross E can be written as del dot E minus del square E, which is equal to minus mu into dou by dou T of J is equal to one more equation. So all the equation I am listing out here, J is equal to sigma E. We have studied, you studied in networks also. J is equal to sigma E minus of mu into dou. So D we will substitute as epsilon E. So it will be 2 times. So it will be dou square by dou T square into epsilon E. So you will get this equation, square E equal to minus mu sigma into dou E by dou. This derivation is very important. Square E by dou T square. So we have reached this much. So now we will write this in the form of wave equation. So this is the wave equation. In last case we didn't have sigma, right? So del square E is equal to mu sigma. So you know there is a company named mu sigma. So mu sigma into dou E by dou T into mu epsilon into dou square E by dou T square. So this is for similar equations for a magnetic field. You can write del square H is equal to mu sigma into dou H by dou T plus mu sigma into dou square H by dou T square. So this is the, like in a medium, for a conducting medium, this not propagating medium. So this is the wave equation that you should derive in a conducting medium. Wave equation for a conducting medium. So now if you are attentive, you might know, if you put the value of sigma equal to 0 in this equation, you will get the case of free space, right? Which the equation which we have derived for sigma equal to 0, that is for free space, right? So this is for a wave. If you put sigma equal to 0, that will lead to case 1. So sigma equal to 0, if you put, you get case 1. So sigma is equal to 0, that's it. So very simple. So these derivation and these things you should understand. And then now we will see what is a propagation constant, intrinsic impedance, phase constant, and what is attenuation constant. For that also, what we are doing, we are depending on the Maxwell's equations. Okay. So let me see if you have any doubts on this. So we know that, you know, the basic equations, which are del dot D is equal to rho V, you know that. Del dot B is equal to 0. Then you know del cross E equal to minus dou B by dou T. So now from here, you should be more attentive. Some new things I am going to say, which you already know, but you should remember. What is it? What is dou by dou T? If you are writing dou by dou T in complex terms, dou by dou T can be, dou by dou T is same as j omega. If you remember what you studied in, you can write minus j omega into B can be written as mu H, right? Then we will again go back to the older equations, which were del cross H is equal to J plus dou D by dou T. Then we substitute whatever we know, del cross H. So J equal to sigma E. So we substitute sigma E plus J omega, and D is written as epsilon E, right? So D equal to epsilon E and D by 2 epsilon E, right? So this is one main equation. So we are now going to work on this equation. So let's see what we'll get. Del cross E is equal to, so del cross E is equal to minus dou B by dou T is minus j omega mu into H, right? So now we will take take curl on both sides, take curl on both sides, then it will become like del cross E equal to minus j omega mu. The curl is equal to minus j omega mu into sigma E plus j omega epsilon E, right? Sigma E plus j omega epsilon E. So it will become minus j omega mu into sigma plus j omega epsilon into E. Then you know the formula here, del dot del, right? So it will be minus del square E is equal to minus j omega mu into sigma plus j omega epsilon into E, right? Minus del square E is equal to minus. Take out the negative sign. Del square E is equal to j omega mu into sigma plus j omega epsilon into E, right? And now listen carefully. Gamma square, we'll consider gamma. So gamma equal to j omega mu into sigma plus j omega epsilon, which updates our equation to del square E is equal to gamma square E, because this much term is, I'm using a different vacuum today, so it is very smooth, so that's why, maybe because of that. So gamma square H is equal to, same way, this is for an electric field, and for a magnetic field also we can, del square H is equal to gamma square E, same things you can write. And this is called, so there was Mr. Helmholtz behind these derivations. So as a respect for him, these equations are called Helmholtz equations, okay? And the thing you should know is gamma mu into sigma plus j omega epsilon, where and gamma is also written as, so gamma should be a combination of a real part and imaginary part. So alpha plus j beta. So these things you will study in more detail. So continuation, as a continuation to this, you are studying these things in your power system. Next semester you have power system. So this is the basic. So you study the basic from here. So what is gamma? Constant. Gamma is the propagation constant, and alpha is the attenuation constant. And beta is the phase constant. So beta is the phase constant. So we have reached up to here. Now, what we will assume? We will assume only along one direction. So in the for the explanation of uniform plane wave, we consider that the wave is moving along only z direction. So here, that is just for a theoretical explanation. So here I am considering along the x direction. So Ex, Ax, that is along, that is only the, sorry, actually this is along the z direction only. Sorry, there is a mistake. So we are considered x component. I told you we have the x and y component, right? Because x, it is on the xy plane. So here we consider only the x component. Only x component we are considering, which simplifies our equation to del square E is equal to dou square. Del square E means 2 times, right? So dou square Ex by dou square Z square is equal to gamma square Ex. Then Ex of Z, that can be written as C1 into e raised to minus gamma Z plus C2 into e raised to gamma Z, where C1 and C2 are complex constants. So that is real plus imaginary, right? It's the same complex constant. So this is actually some basic mathematics I'm talking about. So this can be updated as A into e raised to j phi 1 e raised to minus alpha Z into e raised to minus j beta Z. Because how we are getting is gamma we are replacing with alpha plus j beta. So here gamma is becoming alpha plus j beta. So e raised to terms will come 2 times, right? Because e raised to x into e raised to y is e raised to x plus y. So e raised to x plus y means it is e raised to x into e raised to y. Same concept. So e raised to minus j beta Z plus b into e raised to j phi 2 into e raised to alpha Z into e raised to j beta Z. So this equation you will get. And then you can see that e raised to j 5, e raised to j phi 1 is there, e raised to j minus beta z is there, right? So this, the time varying equation, which is depending on z, that is, which is propagating along the z axis and varying with time t, that is x component. This is how you should read. The x component of the wave propagating along z direction with respect to time t. So we are considering only the real part. So real part will be real part of e of x of z into e raised to j omega t. So this is the time varying field. So what we will get? A into e raised to minus alpha z into, so one more thing, one more entity you should know, e raised to j phi 1 into e raised to minus j beta z. So from this equation, e raised to j phi 1, e raised to j minus beta z, they can be written as e raised to j into phi 1 minus beta z, right? Which makes it, now also you know that e raised to j theta means cos theta. These things you should know, you might have studied in your complex variables and all. Cos theta plus j sin theta. So which updates the equation to cos of omega t minus b, cos of omega t minus beta z plus phi I plus beta e raised to alpha z into cos of omega t plus beta z plus phi 2. So I guess that you might have having some doubts or something might not be clear in the steps here. No problem, and I will clear your doubts if you have any. So don't worry, just go with the flow. So what we are doing now, we understood that e raised to minus cos, you are getting a e raised to minus some term into cos, right? And b e raised to some term into cos. So a for both a and b. So minus beta z means wave propagating along plus is wave propagating along minus z. You see, so what we have seen, so I'll just summarize. So what we have seen, so we have derived the Helmholtz equation, that is gamma square is equal to del square E. So we reached up to here. So del square E is equal to gamma square E, where gamma is the propagation constant and gamma can be written as alpha plus j beta, attenuation constant plus the phase constant. And then this same electric field, we took only the, you know that electric field is an electromagnetic field. So that we took only the x component of the electromagnetic field, which is propagating along x z direction and varying with respect to time. So that is ex is at ax, only the x component. And then we wrote it in terms of gamma, that is c1 e raised to minus x plus c2 e raised to gamma s. And gamma, you know, it is equal to alpha plus j beta. So that gamma value you substituted here, and we got it like e raised to j phi 1 into like the same equation. How we can use the cos and sine components. So e raised to j theta can be written as cos theta plus j sine theta, right? So we took the real part. So we took the real part, which is the cos component. So we wrote it like e raised to minus alpha z into cos of omega t minus beta z plus phi I, phi 1 and beta e raised to equations we got. That is, we took the real part. Okay. So now, so two waves. So actually, what is this? Cos theta, it's a wave, like it's a wave, right? So e raised to cos theta means it's an sinusoidal cosine wave. The cosine wave is depending upon the value of e raised to alpha z or e raised to the e raised to factor which is attached to it. It will become clear for you now. So plus beta z is the wave propagating along minus these two things. You got it. So from the equation, you can see that cosine is multiplied. See, cos raised to minus alpha z, right? So cosine means like this, right? This is a cosine function. So cosine function is like this, but for a conducting material, you need to multiply the e raised to minus alpha z is coming. So how is it? How it is coming? We know we brought in sigma. So alpha is so all this derivation is it is attenuating. So e raised to factor sharply attenuating. I think you understood the concept. For a conducting medium, what is happening, right? So this is actually the base of the derivation. So and then what we have? So what we can write? Ex is equal to ex plus into e raised to minus gamma z plus ex minus e raised to gamma z. So you know that because we are considering only the x component, and you also know del cross E is equal to minus j omega mu h. So del cross, what we mean by del cross? Del cross means we are taking the cross product, right? Ax, Ay, Az. So dou by dou x component we are taking. So Ex will be here, and then it will be 0, 0. Right? So when we take the cross product, the LHS will become like Ay into dou by dou z of Ex minus Az into dou by of Ex, which is equal to minus j omega mu h. So because why we took y and z as 0? Because we are considering only the x component, no other reason, no other technical reason for that, because we are considering only the x component. Okay. So here we got this equation, right? So this is the equation that we arrived at. So what does that mean? So we can write it like Ay dot dou by dou z of Ex minus Az into dou by of Ex is equal to minus j omega mu into Hs Ax plus Hy Ay plus minus j omega mu h, and h we are substituting. So, but we are considering only the, please wait. So what we should do, we can compare the corresponding components, right? So comparing LHS and RHS, we can compare. So compare dou z of Ex is equal to minus j omega mu Hy. So Hy can be written as Hy is equal to minus j omega mu into dou by dou z of Ex is equal to minus j omega mu into dou by dou z of Ex plus into e raised to minus gamma z plus Ex minus into e raised to gamma z. So which will become minus 1 by j omega mu Ex plus into minus oops. So in this particular equation, we are comparing the left hand side and right hand side. So what will happen? Dou by dou z of Ex will be equal to j omega mu into Hy. So fine. So Hy will bring to one side. So 1 by j omega into dou by dou z of Ex. And so what we are doing is we are finally deriving the equation for intrinsic impedance. So this will actually take you to what is intrinsic impedance. Hy is equal to minus 1 by j omega nu Ex plus into gamma into e raised to minus gamma z. Okay, for examination point of view, you need not write this much derivation. Next, I will be teaching you phasor representation. So you can write directly. So, but this is the complete step. So those who want to understand can learn the complete this steps also, because some mathematical derivations are coming, which is not that much required, because you don't need to do this much analysis. You can directly write. Yesterday, if I told you, you can skip some of the steps. I will tell you which are the steps which you can skip. But this is the complete derivation. So I will just share and then you can understand. So from the equations we reach Hy is equal to gamma by j omega mu into Ex e raised to minus gamma. So we have reached here. So here we can see that there is j omega mu by gamma, j omega mu by gamma is equal to Ex into e raised to minus gamma z minus Ex minus. So what does these expressions means? The propagation of wave along the plus z direction as well as the propagation of wave along the minus z direction, right? Divided by Hy. So here we have seen that we have taken a ratio of electric field to magnetic field, right? So this ratio of electric field to magnetic field is called intrinsic impedance. So this is called intrinsic impedance. which is represented by the symbol eta. So eta is written as j omega mu divided by gamma. So we can write j omega mu divided by root of j omega mu into sigma plus j omega epsilon. So now if you see, you can understand that intrinsic, if a question comes, what is intrinsic impedance, you can directly write j omega mu by gamma, and for gamma, for expression for gamma you have derived here. So from up to here, you have derived gamma. So this slide number 8 and 9 are actually a detailed understanding, but you need not, if you find it difficult, you need not study these steps. Those who are interested can study. You can skip these steps and directly write what is intrinsic impedance. Okay. So intrinsic impedance is the ratio of electric field to magnetic field, that is j omega mu by gamma. So you may get a theoretical question. That time you can just write directly. So these in between steps, if you find it difficult, you can skip. Okay. So directly you can write what is intrinsic impedance. So how you are getting intrinsic impedance from the equation is what I have shown you here. Okay. That's not really required. Even if you skip that step, you will get full marks. So what is intrinsic impedance? We need to define. So intrinsic impedance, it is the ratio of amplitude of E and H of the waves, so electric and magnetic field of the waves in either direction, so positive or negative direction. It is denoted by eta, and unit will be ohm. So unit is ohm. So by equation, if you are representing, eta is equal to Em plus divided by Hm plus, or it can be even Em minus Hm minus. So now you can see what I have taught you. The same thing. So instead of directly giving you what efficiency, sorry, not efficiency, even the symbol is looking right. Intrinsic impedance eta is equal to Em plus by H. Instead of giving directly, I have just shown you how we are arriving at that conclusion. Like this is the intrinsic impedance. So this is how we arrive. So this derivation to find out intrinsic impedance is not important examination point of view. You can write it directly. Just derive it up to gamma. Up to this much is very important. Up to gamma you should reach. That is, you should reach the wave equation, the Helmholtz equation. You should reach in terms with respect to sigma. That is for a conducting material. For a free space means sigma will be 0. So that thing you should write. Up to here you can write. Then you can directly write intrinsic impedance, which is the ratio of amplitude of E and H in the same direction. So it will be Em plus by Hm plus as well as Em minus by Hm minus. So how you are getting this? That explanation is this mathematical steps. So there is not necessary, if you don't want to study, you can directly write it here. And if a question comes, you should write it like Em plus is the amplitude of wave component of electric field traveling in positive direction, and Em minus is the component in negative direction. So this much thing you just need to understand. So these steps also we can shorten, and we can write the finally intrinsic impedance will be root of j omega mu divided by sigma plus j omega epsilon. So you have reached here. Okay. Now we are moving further. We can see. So it's now we have defined what is gamma. So gamma is alpha plus j beta, right? Gamma, you know, eta, not efficiency. Eta, intrinsic impedance also you know. Now we need to find out an expression for alpha and beta. Let's see. We have gamma is equal to root of j omega mu sigma plus j omega epsilon. So this we have derived, and it is very important. You should know how to derive it. Okay. So gamma square is equal to j omega mu sigma plus j omega epsilon. So that's also clear for us. Now you know that gamma is equal to alpha plus j beta, right? So for gamma we substitute alpha plus j beta. So gamma is equal to alpha plus j beta the whole square is equal to j omega mu epsilon minus j into j will become j square is -1. So minus omega square mu epsilon. So we are going inside. Now we will use the property a plus b the whole square. So it will be alpha square minus beta square plus 2 into j into alpha beta is equal to minus omega square mu epsilon plus j omega mu into sigma. Then we can write alpha square minus beta square is equal to minus omega square mu epsilon. So what we are doing, we are equating the real parts and imaginary parts, right? We are equating the real and imaginary parts. So real parts this will equate, and these two also we will equate. So alpha square minus beta square, this is beta only. Alpha square minus beta square is minus omega square mu epsilon. That we will consider, we will give a name equation 1. Then we can write 2 alpha beta is equal to omega mu sigma. So that will be equation number 2. So substituting and combining these equations will give us beta is equal to omega mu sigma divided by 2 alpha. Okay. This equation you name it as equation number 2. So this should be equation number 2, and then substitute equation number 2 in equation number 1. Put 2 in 1, then alpha square minus what is beta? Beta square will become omega square mu square. Omega square. I'm using a new vacuum, so it's very slippery here. Omega square into sigma square by 4 alpha square. So 4 alpha square is equal to minus omega square mu epsilon. So then you take LCM and do whatever steps you need. So these steps are very important. Usually they ask it for 10 marks directly. Mu epsilon into alpha square minus omega square mu square sigma square by 4. These steps you should try on your own. Okay. So alpha square is equal to minus omega square mu epsilon by 2 plus minus omega square mu epsilon by 2 root of 1 plus sigma square by omega square epsilon, that is equal to omega square mu epsilon by 2. You took it as common, minus 1 plus minus root of 1 plus sigma by omega epsilon the whole square, which gives us alpha square is equal to omega square mu epsilon by 2 root of 1 plus sigma by omega f. It's all we are doing mathematical arrangements only, okay? Minus 1. So what will be alpha? Alpha is equal to omega into root of mu epsilon by 2 bracket root of 1 plus sigma by omega epsilon whole square minus 1. So that is alpha. And on similar terms, because we know this, so if you find alpha, you can substitute it in this equation and find out beta. So you need not do that derivation also. You can write. So if this is equation number 3, put 3 in 2 and you will get beta is equal to, you should know this equation. So it's better you can by heart the equation, but you should know how you arrive at this equation. Sigma by, because based on this equation only we are deriving other conditions. So based on this equation, we will so if it's a lossy medium, like if sigma is equal to 0, sigma is not equal to 0, such conditions we take and then we find out what is the result. So this is how we find it out. Okay, this root is complete. Okay, so this is not under root. So this is under root. This is not under root. All these things you should understand, alpha, beta. So in some textbooks it will be given like raised to 1 by 2. So all these things